This is jambots.com/canvas coder. Canvas Coder is an HTML web-based drawing program with a platform for sharing HTML5 Canvas drawing code. And it's got some tools to help edit, and it makes it real simple to start modifying This is jambots.com/canvas coder. Canvas Coder is an HTML web-based drawing program with a platform for sharing JavaScript and HTML5 Canvas code. It's meant for education, and it's meant to make it very easy to get started coding to Canvas and to get immediate feedback and to be able to quickly find examples of drawing and animation that you can use in your own projects. This first view is a drawing program. It's just a demo so that the touch events create instances of these animation code blocks. Now, if we want to look at the code that creates, this is Amy the Amanita, mascot of Canvas Coder. Here's Amy. Now, say if we want to change Amy's color, say Amy is turning purple, we'll get down here to where it says red. We'll just change that to purple. And then we also might want to change up the dance a little bit here. We'll give Amy a kind of a hyper dance move here. There we go. Now we go back to the scene, and all the instances have inherited that. We get a little bit of a perspective effect in this view. There's also a flat view for more of an illustration look. We can use this nav bar here. These are in local storage, and each of these has its own code that we can look at here. In this case, the rocket is going to take off every 3 seconds. It's a sawtooth wave. So you can learn basic program flow and mathematic concepts here. Now, if we go back into the load button, we can load up the basic drawing elements that you'll always use in HTML5 Canvas 2D context. The fill, rect, line, arc. The two different kinds of curves. That's all there is to it. Within this, it also addresses getting the context, scaling, line width. All of it is proportional so that this code can wake up in its context and behave appropriately. Let's look at the Bezier curve a second here. Click on Edit Code. Now, in this example, it has the SX and SY is the start point, and CX and CY are coming from the self object, and they represent the pixel value of the center area. And then the grid is also defined in here, so you'll draw everything relative to CX and CY, and then multiply it by the grid. So in this case, say I wanted to move control point 1 all the way over here. So CX will be +4, CY -4. So I go down to control point 1, which is in orange, and we'll go make the CX +4, run that code, and you'll see how the control points affect the Bezier curve. Second section in the syllabus is programming tricks. We have some basic JavaScript, and this is what makes these blocks of code so much more powerful than a video, for example. That you can do some amazing things in After Effects, but with this you can have interaction and animation that responds to the environment and can be controlled programmatically. So if you have a game, you might want to change up how the animations work. And the beauty of this is it'll work on any platform, every device, every operating system, they all have browsers with HTML5 Canvas and can run apps that use the HTML5 Canvas to draw. It's also often hardware accelerated, and so this is going to be an important form of art in the future because it's the only universal way you can distribute code to represent visuals effectively. Also animation and complex mathematics. So you have just your basic for loop, RGB color that deals with concatenating strings and variables to create essentially CSS color definition strings. JSON, that's where you explicitly code JavaScript object notation, and you can make a little configuration object for your code so that you have a little control panel at the top of your code and you don't have to dig around all of your long loops. Vectors are important for any type of drawing where you're going to be moving in a direction at a certain degree. It's called turtle graphics. So you'll see there's examples with iteration where the degrees are progressively changed, and it's good when you get into this that you're going to become familiar with radians versus degrees and how those are proportionate to the x and y vectors when you trace the circumference of a circle with a triangle. It looks complicated, but you're going to see the same thing over and over and over again if you work with geometry. Another aspect that we have in this tool that helps, aside from this thing that helps you check where points are, you can also add graphics as sort of a light box. So you can say, oh, I want to redraw this pylon in vector graphics. And once it's a vector, I can show it on a telephone, or I could project it on a at a concert in 4G, 4K. And there'll be no loss of quality. Whereas if you scaled up this raster, it would look terrible. So this is really a powerful platform. I'm going to get rid of this file here. Back to the load. Conditionals, modulo, iteration, fractals. These are powerful programming techniques that you can use in visual graphics. In fact, let's draw a scene with this fractal tree, and you can see that the geometry of the tree changes according to where it's being drawn. It tends to lean in from the outside, and in the middle it's symmetrical, roughly. And then as it goes up, I have it set to respond to its environment by becoming more, having longer branches. So this way you can create a sense of continuous variation with one single code block. Let's get into the next section, which is animation. That's where we take time and use the time effect to change the parameters of the drawing. In the case of the Pac-Man, we have a sine wave used to create the smooth animation between the mouth being closed and the mouth being open, and it speeds up and slows down continuously and gives it a very natural looking motion. Here's an example of a gear made using it's a type of inverse kinematics. You see there's a constraint on this. It's like a push rod from a steam locomotive, where this is all just basically solving using sine and cosine and the Pythagorean theorem to determine what's the solution to this rigid body. And if we go into this code, there's a couple of things we can change up. We can give it, say if we wanted it to have 18 teeth. Okay, now it's got more teeth. Maybe we want it to run backwards, or make it run a bit faster. So you could easily copy this code into different size gears and then have them instantiated in your drawing environment such that they're in sync, and the gears would be enmeshed. If you drew them in the right place at the right time, then they would continue to just push on, and it abstracts the drawing from the game logic, which you would still have to do. We're going into private beta. If you want to get in on this, send me a message on Facebook or email me, tschubring@gmail.com. I'll get you a username and password. You can go in and grab this code and start making your own games if you want. You can also go in there as a guest without a password, jambots.com/canvascoder.